show two things. I need to show that stem cells from the bone marrow can release themselves, travel to the pancreas, migrate into the pancreas, and transform into natural insulin-producing cells. If I can show that that phenomenon is natural, then the second part is to show that by putting more stem cells in circulation, I can enhance this natural process to a point where it has an effect on the development of diabetes. Fair enough? Is it too technical so far? It's good. Okay. This is a very ingenious study, so I'll try to make it simple. So scientists took male mice. So what they do is that they take the first cell, the egg that had just been fertilized, they take that first embryonic stem cell, and then they do a genetic manipulation. They couple the gene for insulin to the gene for green fluorescent protein, which means that in that animal, when the animal has fully developed, any cell in that animal that starts to make insulin will also make green fluorescent protein, so you put a black light and that cell will glow. Okay? Now they irradiated female mice, which kills all the stem cells, and they injected stem cells from these male mice to these female mice. Meaning, I have female mice, all their body is made out of cells that have the double X, no Y chromosome. So if I find in that mouse a cell that has the Y chromosome, I know that it comes from the stem cells that I have transplanted in the bone marrow. And if any one of these cells starts to make insulin, it will turn green. Okay, so they looked at a few cells from the pancreas a few weeks later, and if you look at that one cell and you put a black light, it glows. So that means that cell that is in the pancreas has transcribed the gene for insulin. Now the question is it making insulin? Using a red dye for insulin, that cell is actually making insulin. And it's not a Frankenstein cell, it's not an overproductive cell, it's not a sluggish cell, it's a very normal cell of the pancreas. Look at it between these two other natural cells of the pancreas. And the message here, if you follow well or if I explain well, the message is that you will see that today at the age that we all are here, except maybe one, the younger one, we don't have any cell in our pancreas that we're born with. They've all gone and they've all been replaced exactly like what that cell has done. Leaving the bone marrow, going to the pancreas, and just replacing the cells that are being lost. And it does have the Y chromosome, so it does come from the bone marrow. So that study alone shows very clearly that stem cells from the bone marrow can naturally go to the pancreas and become insulin-producing cells in the pancreas. Fair enough? Yeah. So next study, if I put more stem cells in circulation,